Oh, welcome to a delayed version of Sunday Science here on Monday, everybody. Glad you could join us. Gonna be a little slow on the show today. I have a partially herniated disc in my neck, and when it flares up, I gotta take a muscle relaxer, so I'm just moving kind of slow, but still glad you guys could all join us. Just gonna be going through a little bit more zap today and going through the Tesla coil build and things of that nature, and yeah. So with my Tesla coil not wanting to fire up last weekend, it went through a little bit of a changeover. First thing I had to do was modify my transformer, and well, I won't show you the inside portion of the modifications, but I'll go ahead and present real quick and show some of the build on my end. So it's that one. All right, hopefully you guys can see the transformer up now. Not sure if you can or not. Seeing that, Size Strike?
I am not. I think we have your other screen that has the Hangout.
Well, that's not the right screen.
I hate when that happens.
Let's try again.
And the odd thing was, I had it fully expanded over here, so it appeared to be my screen, and I was clicking, and it said I was presenting, so I was clicking on your icon to present, but it was an image of your Hangout session.
Interesting. Why in the world can I not see this? Let me try and move the chat over on.
What about sharing an app instead of a screen? Will it share a picture viewer? Maybe that's
what I was. No, it's not showing my. What in the heck?
yeah.
All right, let me get Corel open and I'll do it there. Hopefully it'll share Corel. What to do?
Paraners tech gremlins.
Oh man, I can't find any of these things. Oh, lots of pictures of my dog. Where in the world's my Tesla coil build? Why are these not in order?
Should
Maybe?
There
it is.
Ah, yay.
Alright, now maybe I can show it in a Corel window.
All right.
Ah, it likes Corel.
Oh, cool. Ah, perfect.
Alright.
We see.
So under this fancy little cap with this nice little charred thing you can see there is the ground fault interrupt circuit that neon sign transformers kind of have to be built with these days. And you can see from the char, I blew up the LED with a little bit of a feedback surge, so I went ahead and pulled that cover off, pulled the old terminals out, and pretty much depotted that entire side, which the electronics are all encased inside of a epoxy junk. So you have to drill it all out and bust it all apart, and finally got back to the actual lines going to the center coil. So neon sign transformers, if you're not sure, they're center tap. So as opposed to like a microwave oven transformer that's a coil next to a coil, this is a coil in between two other coils. So you basically have one line coming out at 6,000 volts and another line coming out at 6,000 volts. It makes it a lot easier for insulating and making things, instead of having to actually insulate for 15,000 volts, you only have to insulate for 7,500 volts. So, but all that ground fault interrupt circuit has been completely removed, and modified a little bit there. Let's see if I can grab some more of this build here. This is gonna go back ways. Might as well show you the pretty much the finished build as it sits right now. So nice big primary. I got 12 lines on that. Secondary, like I was saying, is the 962 or so turns. Toroids all aluminum. It's a semi-rigid dryer duct, and like I was saying last week, a couple of pot pie tins for the top and bottom. It works actually quite nicely. Down here you got spark gap, and kind of hidden in there that you can't see, but I'll open up some other pictures, is the capacitor bank, and I'm going to have to get some more capacitors, because even though I got the right voltage, when you run capacitors in series, you up your voltage and you drop your capacitance. So with the 6 caps that I have in there now instead of a homemade one, because I tried the homemade one again and it still shorts out, so that one's just not going to work for me. But I need to do some in series and some in parallel so that I can get back to the resistance that I need. Right now I'm about a factor of 10 low. So let's show you that capacitor bank here real quick.
I'm having a world of headaches with those capacitors we bought.
Yeah.
I mean, they're obviously of decent quality. I mean, none of them have. I'm running them. I just have the series is only 2, so really it's only expecting about 20,000 volts, and you're supposed to operate at about half. I'm not. Mm-hmm. I'm not. They're charging to a full 20,000 based on the spark. Oh, there it is.
Yeah, so there's my little capacitor bank. It's just some foam, foam tape to help try and keep any vibration limited and keep everything bolted down. So that was actually right before I went and soldered the whole daisy chain together. But that's one cap bank, and now I get to make several more of them. Like I say, I'm about 0.7 nanofarads. I want to be around 9 nanofarads. So yeah, that's just not quite enough, but I'll just keep showing some more of these here real quick.
I've said it before. I've said it before. Your final construction there is very impressive looking. Mine is constructed on top of a crate. I like the aesthetics of what you have produced.
Well, just because it looks good doesn't always mean it works right. So here's with wanted an insulator board between the transformer, and it doesn't do a whole lot of sides hold on some of the terminal blocks here. Power in actually used to be from my CNC router that I had built that I tore apart to make telescopes instead. A weird person sometimes, I think. So power in, jumps off, ground's obviously hot and neutral, 2 hot leads flying out into the capacitor bank. So once that goes to the cap bank, I just did a bunch of pictures while I was building to show various parts of it. Maybe. Yeah. So up to another terminal block with both of the hot leads. And then these jump over. Connections ran through the back side of this board, actually. And then ran, one leg down out into the spark gap. Spark gap goes up to the primary, other ends direct into the primary. So I get real finicky about things looking a very certain way when I build stuff, so I probably could have whipped everything together a lot quicker and a lot easier, but I do like neat wiring. I just gotta do it that way.
I was going to bring that up. There were several jokes about safety before when removing the factory installed ground fault interrupt on the transformer. Safety is not to be ignored. I will direct your attention to Andy's extremely diligent and correct wiring methods. Safety is to be observed, just not when it gets in the way of Zap Zap, obviously.
Indeed. So these are the connections running through both to the capacitors, both to the capacitor bank, and then off to the, this right now it's just hooked to a spool, but that actually runs off to the primary as well, and then the other lead down here goes to the other end of the capacitor bank, and it's same thing into the spark gap. I've got to change my settings so I keep going back to the same place. This is boring.
Hey, Bo mentions burnt skin in his comment. Were you watching me when I was setting up the Tesla coil? How would he know about the burnt skin?
Oh man. So this was spark gap round 1. This got changed out from brass knobs to number 4 solid copper electrodes that I ground down. I'll pull up a video of that arcing, but I have a lot of different videos on my phone, so I'm going to stop sharing here for a second and see if I can find this video. It's going to take a little while. So, what's your construction looking like there, Si?
Well, basically, I removed the homemade capacitor. All the plates of glass with the aluminum, and that thing was actually doing rather well. No arc over or anything like that, and thanks to dollar store picture frames, it was cheap. So you get the normally glass is not a cheap item, but
Indeed.
I may be putting it back in at least until to get the capacitor. I may have to order some more to make a proper bridge to get the right value. It's either too high, in which case I can't get the thing anywhere near resonance, or too low, in which case your spark gap gives you a little drizzly spark that, I don't know, it's just it's not capable. It's not a pulse spark that'll produce the basically radio frequency oscillations that the coil needs to put out anything interesting. So
yeah,
that's I'll get them eventually. I'm going to order up some more of those caps, and I may double them so that the entire bank of capacitors will be rated at 40,000, because running a insulation geared for 40,000 at 20 is good. Running 20 at 20, it's a little risky. So
yeah, a little bit.
But it's things are basically as they were. I was actually tempted to haul down the old. I don't have a new oscilloscope. It's a very old one, but this is definitely within the frequency range that's expecting. I was thinking of doing the real calibration way for these things, which is what we're doing is sort of what we call loose design. It's with the variable coil. We design it so it's close. We know it's close. It's in the range, and then we just adjust the coil to tune it so that it's to resonance. If we wanted to go all nuts, And by the way, the results are the same if you do it the alleged right way. You end up with the same results. But what you're supposed to do is put a signal generator through a capacitor to the primary, and you're supposed to have the oscilloscope through a capacitor close to the secondary, and you're supposed to be able to track the pulses. You'll see the initial pulse from the signal generator on the primary energizing the coil, and then you'll see the resonant pulse like a wave very close to it. And that way you can tune your coils so that the frequencies are very close. Now, you don't want them exactly on. The primary is supposed to be resonant a tiny bit lower, because when you fire the thing up, as soon as it makes the visible streamers, those visible streamers are conductive, and since those are coming out of the top load, and when you hear top load, think capacitor, everybody. When those streamers appear at the top load, they are conductive. They actually increase the capacitance a little and lower the resonant frequency of your secondary. So if you do that method and you tune them so they're exactly in resonance with each other, as soon as there's any discharge, they'll be out of resonance, and it won't, and you get nothing. So, but anyway, that is the right way to tune one of these. It takes, I would imagine, 4 to 8 times as long as doing the build it somewhere in the range and then tune your coil by hand. I'm going with what we did. Anyway.
Yep. Indeed. All right, I found 2 videos that pretty adequately show the new electrodes, that setup, and then them firing at night. You can tell that I obviously don't have the capacitance that I need because, yeah, only the spark gap's firing, but hey, it's better than the transformer blowing up. Well, it's better for me that the transformer didn't blow up. It's always fun to watch a transformer blow up. Kind of scary, but... Alright, so this shows how it's just solid number 4 copper that I took to a belt sander to grind some electrodes. Sure, probably could have used some welding rods, but I don't have those. I have lots of copper, so... And obviously, I'm not firing this up indoors at all. But getting a lot of arc out at the spark gap, and that should be pulsing much more, not just this direct flow, so...
You'll need to do some sharing. You'll need to do some sharing, Andy.
I don't know if you can hear when I'm...
Oh yeah, I got the sound, but you're not sharing the video yet.
How am I not?
Well,
it says I am.
Odd. I see nothing. Let me go to the thing. You're presented. You know what? That happens. Stop sharing and then start again. I've had that occur. That's why at some point we may start using, we plan on using the communications features in Discord to do these group things.
Yeah. Are you seeing my video editor now?
I got nothing.
Let's
see, and I have... Oh, wait a minute. Yes. Yep, gotcha. There you go. What'd you do?
Okay.
Whatever you did, it worked.
Oh, as long as it works.
Absolutely.
Alright, so there's the new electrodes instead of the... You could see the scorch marks on the brass drawer pulls. They were just Jacob's laddering, and it wasn't so awesome, so... There's that starting to fire. That's about as close as I'm willing to get. And it should not be running like this. Like I say, it should be much more pulsed and things of that nature, but hey, it's something sparking, so that's always fun. And at nighttime, because you have to do it in the dark.
Indeed.
And obviously still not getting anything into the secondary, but hey, it's pretty.
Yeah, see that I had that with the new caps. That's the kind of spark I was getting. Not a pulse, just a continuous. Would be great if we were making more Jacob's ladders, wouldn't it? But
It would. Which, oh, what the heck. Oh, yeah. This is always fun. So, like I say, blowing up transformers does happen quite regularly.
much to the dismay of the neighbor, as I recall.
Oh, yeah, that neighbor just doesn't like me all that much. It's okay. It works.
Damn anti-science neighbors.
I know. Good grief. So, hopefully, throughout the week, I'll get something going better with the... going a little better there with the capacitors and get some better results, but that's about, yeah.
That's another point. That's another point on those caps we bought. They store a charge a hell of a lot longer than the homemade ones we had. So
yes, they do.
Yeah. I'm not saying how I know that, but they do.
Well, as long as you have a good resistor handy.
Funny how you had good resistor, and really it was in another word, but the word hand in the same sentence. Anyway, that's
oh man.
Yeah, it's gonna take some some fiddling with the new caps instead of the homemade ones, but once we have them in the right range, they're going to be a lot more effective because we had a lot of, even though careful construction techniques, et cetera, in order to reduce the corona loss in the glass one I made. What you're supposed to do is submerge the whole thing in mineral oil. I do not want a tub of mineral oil in my Tesla coil.
No, absolutely not. That would be quite messy.
Enough fun lifting the thing and carting it around the house now.
Right? That's why I put wheels on mine.
Oh,
I still have to carry it down the steps, but then I can just roll it around.
Yeah, my father. I wish he was still around. He would love your construction. He was famous for the phrase that do a good job, but when it looks good, then you can say it is good.
Right.
mere functionality, that's not sufficient. It has to look good as well.
Indeed. So. And speaking of Jacob's ladders, I finally found mine. Sorry, there's so many videos I don't want to just be clicking through them trying to find the right one. So I'll try presenting again and at least showing off this pretty cool looking Jacob's ladder that I made.
Oh, indeed, please do.
I always got to have some kind of something with sparks. And hopefully this time it just works.
There you go. Yep, you're up.
All right. So not really a traditional Jacob's ladder, but it was a lot more fun. So all in all, it's about 3.5 feet worth of double helix that thing walks up.
I have to admit, that is the first helical Jacob's ladder I had seen when you constructed that.
I don't think there are very many of them out there.
No.
I don't even know why in the world I thought up the idea of making that, but...
Oh, hey, Bo says Sean's coming up with the stream over there. I had no idea he had one going on. Huh, interesting. I did not know.
Huh, me either. Might want to hop over there.
Indeed. Should we? Do you want to? Should we just show some zapping to? It has been requested. I just kind of put all the I just kind of put all the past zaps into one exported video. So if you want to play that, I certainly could.
Yeah, sure. Let's give that a shot and see what Sean's up to.
Alrighty. Like Sean, he knows stuff.
Indeed.
Alrighty. Here is the compiled zaps. Some before final construction and assembly had occurred. Here we go. This early stages. Let's make sure this is going to work. Which it apparently did. End result of all that earlier stuff. This was the baby coil.
Why don't I see your screen?
Oh, I am not sharing. Yeah, probably do something about that. Yeah, I didn't want to take over your presentation, so.
Oh, no worries.
You see?
Oh, yeah.
Alrighty.
Still thinking of making a breakout point like that. Just
yeah, it's a good one to clip on, but when you finally get it to resonance with a smooth top load, it'll do a very interesting looking corona around the top. Now with the top loads, we both seem to have constructed exactly the same kind, almost as if I saw yours and said, "Hey, that'll work." But because they're not smooth, each of the ridges is acting as a rather inefficient breakout point. So without a sharp edge, we may not get a lot just from the top load.
yeah.
Still the baby coil. Yep.
So that's the Slayer cider coming along.
Not too bad. I got some stuff coming to finish that up. You can see here's the glass cap. You can see that glow, as impressive as it is to see, is not something you want in a capacitor because all of that represents loss. Oh, yeah. here's the big fellow. Up. And I like that one with just the orb radiating. This is a 15 centimeter arc, which puts it somewhere in the 450,000 volt range. And ion drive. Got to build us a TIE fighter.
Yep. Oh man.
And there we have it. That's the zappage for the assembly for today. When the new coil actually gets done and Andy's is functional as well, we will have some kick-ass arcs for you guys to see. Trust me on this one.
Oh yeah.
Hell. Alrighty. We don't normally do this, but you want to wrap it up so we can head on over to Sean and see what he's up to?
Let's wrap it up early today, and we'll go see what Sean's up to.
All right, absolutely, yeah. Like I said, had I known, we would have worked something out, so we weren't infringing on his airtime. Okay. Well, thanks everybody for joining us, and
thanks for stopping by. Sorry for the short show, but it is normally not our show on Mondays, so
and
glad you could join us anywho.
Hope the neck feels better soon there, Andy.
Oh, me too. Usually if I take the muscle relaxers before it completely seizes up, I'll be good in the next day.
That's cool. And good of you to do the show while in pain. Thanks. All right.
Hey, you know.
On to the closing. Thank you, everybody. We'll talk to you soon. And we'll probably see you over in Sean Land.
Probably. Thanks for joining us, everybody.
Wait a minute. No. That's the closing for the other show. That's not Andy's closing. That's just uncool. This is Andy's show, damn it. That's for my show. Here we go. Sorry, Andy, I didn't mean to be hogging your show.
Not a problem.
I just wanted to hear that song again, you know me.
Oh, yeah.